Okay, so what you're going to be looking at in section 4.2 is a particular type of discrete probability distribution, which is called the binomial distribution. So because it is a discrete distribution, you should remember from the previous section that a discrete random variable is a situation where you are counting something. Okay, so because this is a particular type of discrete distribution, you're still going to be looking at a situation where you are counting the number of times that something occurs. And whatever it is that we're interested in counting for the binomial distribution, we refer to that as a success or as a successful trial. So something that you always want to watch out for when you're going to use the binomial distribution is you want to make sure that you're looking at a situation where there are only two outcomes of interest, okay? And whatever it is that you're looking to count, that's going to be classified as your success, and anything else would be classified as a failure. Okay, so just to give you an example, let's say you are selecting cards from a standard deck and you're interested in counting the number of kings. All right, a king would be considered a success because that's what you want to count. So every time you drew a king, that would be classified as one success. A failure would be anything that is not a king. All right, so even though there's lots of other possible cards you could choose, for a binomial distribution, anything that is not a success would be classified as a failure. So that would be any card drawn that is not a king would be considered a failure. Now, in addition to making sure that there are only two outcomes of interest, you also have to make sure that each trial is independent of the other trials. Now, what that means is what happens on one trial does not affect the probability on the other trials. Okay, so going back to my card example, that would mean you would have to make sure that you were replacing the cards every time you drew. Because if you did not replace the card every time you drew, then the number of cards, the total, would be decreasing. It would be changing with every trial. And that would be a situation where you had dependent trials because what happens on the first draw affects what happens on the second draw. Okay, but if you were to make sure that you were just putting those cards back every time, we call that with replacement, then you would know that those trials would be independent because there would always be 52 total cards. Okay, so you want to look for two outcomes of interest, make sure you can classify what's a success and what's a failure, and make sure you have independent trials. If those things do not happen for your experiment, if you can't classify a definite success and failure, and if you cannot ensure that the outcomes aren't changing or the probabilities aren't changing with each trial, then what you have is not binomial, and this distribution will not apply. All right, now, if you do have a binomial distribution, if these four properties are all satisfied, then you're going to classify the values of n, p, q, and x. All right, and I've labeled here for you what each one of those things represents. Okay, so let's go ahead and take our first example, and we'll look at how to label those values of n, p, q, and x. All right, so in this example, we're given information about people's opinions on whether or not the government should help fight childhood obesity. All right, now the first thing that we're told is that 39% of adults feel the government should help fight childhood obesity. Now note that is a probability. A percentage and a probability are the same thing. Okay, so it's giving you a fixed unchanging probability. That's a very good sign that what you have is a binomial because the probability is not changing as you go from one person to the next. Now, to make sure that what I have is indeed a binomial distribution, I'm going to try to classify the values of n, p, q, and x. Okay, so I'm going to start with n. N represents the total number of trials. Right? Basically, how many times are you going to do this? How many cards are you going to select? Or in this case, how many people are you going to talk to? Okay, so I'm going to note right here, I'm going to select 6 U.S. adults. That's my total. Okay, so the number of trials, I'm going to do this experiment 6 times. All right, now P is the probability of success. And remember, success is whatever you're counting. All right, so in this situation, I'm interested in the number of adults who think the government should help fight childhood obesity. And right up here, I'm given the probability of that happening is 39%. So P is that fixed probability of what I'm counting. I'm going to put it in decimal form. And in this case, P is going to be a probability of 0.39. Now, Q is my probability of failure. So in this case, that would be the probability that an adult does not think the government should do this. Whoops. And the nice thing about Q is once you've found P, you can always find Q by just subtracting from 1 because these are complementary events. You either have a success or you have a failure. So if P, the probability of success, is 0.39, then Q, I'm just going to subtract that from 1. And basically that tells me if 39% of people think the government should do this, then 61% of people think the government should not do this. All right, and then lastly comes my X. X counts the number of successful trials. All right, and remember, in this case, what we're interested in counting, our success, this would be the number of adults who think the government should help fight childhood obesity. Now, sometimes you're going to be asked for all the possible values of X, all right? And X will always have values that range from 0. You could have nobody who says the government should do this. And then all counts, remember this is discrete, up to your value of N. Can't go past N because you only talk to 6 people in this case. So you could have 0 people who say the government should do this, 1, 2, 3, 4, 5, or all 6 people might say the government should help fight childhood obesity. Okay, so this is how I identify and lay out a binomial experiment. Now, what I can do if I have a binomial experiment is I can use the binomial distribution to find the probability for a particular value of X. All right, for example, part A says find the probability that the number of adults who think the government should help fight childhood obesity is exactly 2. All right, so that's wanting me to look specifically at 2 successful trials. All right, now there is a binomial formula, and I left up the textbook video. It's underneath this one in the Learn assignment so that you could see some additional examples and also in case you wanted to see the use of the binomial formula. I'm going to encourage you here to use StatCrunch because it has the binomial distribution stored where you can input all your information and it will calculate it based on your values of N, P, and X. So what I want to do at this point when I want to find a probability for a set number of successful trials is I'm going to open up StatCrunch. To get to the binomial distribution, I'm going to go to my Stat Calculators. All right, you got a whole list of distributions there. This is the binomial, so go ahead and select that one. All right, and then all you have to do is put in your values of N and P. Remember, we had 6 trials, and P, the probability of success, was 0.39, 39%. And then right down here, you're going to specify what probability you're trying to find. Now, we want exactly 2. Exactly is equal to 2 successful trials. And when I hit compute, it's technically using that binomial formula that I referred to calculate the probability that 2 people will say, yes, the government should do this. And if I round that to 3 decimal places, I have a probability of 0.316. Now, sometimes you might want to use the binomial distribution to look at multiple values. So like part B says find the probability that at least 4 people at least is 4 or more. So I'm going to go to my binomial calculator again. Now notice N and P don't change for an experiment. Once you determine them, they stay the same. So all I'm going to change is this equal to greater than or equal to, because I want at least, and this 2 to 4. And the nice thing about this graph is it shows me in red which values it's looking at, so I can make sure it did the right thing. At least 4 could be 4 or 5 or 6. So it calculates for all three. It adds them together, much like we did with our discrete tables in 4.1. And it tells me the probability that at least 4 people will say, yes, the government should fight childhood obesity is 0.166. All right, and I can look at any range of values that I want to here. So in part C, if I want to do one more, part C says let's look at the probability for less than 3. So I'm just going to come right back over here, change that to less than, change that 4 to a 3. Again, it's going to highlight in red. That could be 2 or 1 or 0. Add those probabilities together, and I have a probability of 0.565 that less than 3 people will say, yes, the government should help fight childhood obesity. All right. Now, I also put a document on the announcements page that has some screenshots of these exact problems. So if you kind of get in your homework and you forget, you might want to pull those and print them. That way you'll have some good StatCrunch screenshots of exactly what I did and exactly where I went to get that, because that binomial calculator is going to be a very good tool for you here, so you're not having to use the formula every time. If you go to the help tools, you're going to see the use of the formula, and you'll see that sometimes it gets very lengthy, especially when you're looking at multiple values of x. Now, the one other thing you're going to be doing in section 4.2 is using these values to calculate the mean, the expected number of successful trials, the variance, and the standard deviation. And the good news here is that these formulas are much simpler than they were in section 4.1. For a binomial distribution, to calculate the mean, all you have to do is take N, the number of the total number of trials, which was 6, multiply that by P, the probability of success, which was 0.39. All right, so if I just come over here and pull up a basic calculator, six trials times a 39% chance of success, that tells me I would expect 2.34 adults to say, yes, the government should help fight childhood obesity. Now, if I want to look at variation, for the variance, I just need to also bring in the chance of failure, the value of Q. So I'm going to take that 6 times 0.39, and then remember Q was just 1 minus P, 0.61. So if I take what I had, multiply that by Q, then I've got a variance of 1.4274. Now remember, with variance, everything is squared, so I'm not going to put any units on that. But I'm going to use that to get my standard deviation. Standard deviation is just the square root of the variance. And this will tell me how much variation I should expect. All right, so I'm going to take the square root of that variance, 1.4274. And I'm going to go ahead and round this one to 2 decimal places and report my standard deviation at 1.19. And the way I would interpret this, mean I would expect about 2.34 adults to say, yes, the government should do this. I would expect that to vary by about 1.19 adults on either side of the mean. Okay, so these 3 formulas, these are used for mean, variance, and standard deviation. Binomial probabilities are going to be found using the binomial calculator in StatCrunch. All right. Now, like I said, I left up the textbook video. I don't always do that, but I left up the textbook video here just so that you could see some additional examples of identifying N and P and Q and X, and also so that you could see the use of the binomial formula. All right. When you see the use of the binomial formula, know that that is the exact same thing that's happening when you use the binomial calculator. But I want you to be aware of it so you don't get confused when you go in and you possibly look at the help tools and you see it being used there. All right, so go ahead and get into that 4.2 practice. All right, do some work, practice these things, and as always, feel free to contact me if you have any questions.